Hello, okay, welcome to part two of today's lesson. All right, here I am again with the 7 layers of the OSI model. Okay, so I'm just going to take a second and I'm going to remind you of what we've been through so far. Okay, of course, we started off, we actually built some physical network cables earlier. And of course, we've also talked about the concept of fiber optic and how hubs and repeaters work and so on. And then I introduced the concept of something called a data link layer. That was with the very first set of videos as we were plugging things into switches and how switches were different than hubs. Um, and then I moved up and we talked quite a bit about about something called a network layer, which has to do with these things called IP. Okay, so IP, of course, being the IP addresses. We also use lots of pings in order to test our networks, and this happens to be using a protocol called ICMP, which is what we ended up doing all of our testing to make sure that given a packet from one network, we could actually find our way through to another place. And of course, I got you to build up this big, very complicated looking version of the world. All right, so the next step up that we're going to hit is this thing called a transport layer. Okay, now according to this little picture right here, the transport layer has to do with end-to-end communications. Okay, so in other words, we're talking about, we're not so much interested in here in terms of things like switches and routers, but we're actually talking about computers talking to other computers. Okay, and of course, like everything else, I've got some little simulators here that I can show you. All right, so let's get started on this. Now, which one did I pick? Okay, not this one. Sorry, not this one. Sorry, this one right here. Okay, perfect. Okay, so this is what I'm going to look for. What I've got is I've got two computers. I've got the computer on the left who's going to send a message through this thing that looks like a cloud. And of course, what that is, that's the magical part of the internet to some receiver at the other end. Now, what do I mean, the magical part of the internet? Well, what's inside here? There could be all kinds of things. There could be switches, there could be routers, there could be all kinds of things that are going on. All right, and the way I've set this up is I am going to send a message from this computer over to this computer, but what I've done is I've packetized the data into small bits, and I've decided that I'm only going to send 40 bytes at a time. Okay, and here's what we're going to do. So when I click on transmit, we're going to see some data start to go across. Now, you'll see it starting to go. I'm just going to turn down the speed so we can actually take a look at it. Okay, and it says here that the source was 192.168.1.1. That's the computer on the left-hand side. And the destination was 192.168.10.45. That's the computer on the right-hand side. We don't really care how the data gets from one end to the other. It's just a completely invisible sorry, it's completely invisible to us, so we don't have to worry about what's going on. But you'll notice that there's a couple of new things I've added in here after the IP address. No, this is not slash 4500. This is colon 4500. Okay, what this is called the port number. Now, you can imagine that over here on this computer, there could be a whole lot of different things running. For example, okay, back over to here for a second. Remember in Packet Tracer when I got you to set up your servers, there was a bunch of things called services. There was HTTP services, there was DHCP services, there was DNS services. These are all things that you worked with last week. When a packet comes in, the computer needs to know which one of the services to give this to, and the way how this works is the computer uses something called port numbers to figure out which things to hand it off to. For example, if a packet arrives at this server with the port number 80, it's given to the HTTP service. Okay, if it shows up with a different port number, it'll be given to one of the other services. Okay, a little bit more on the services later and what they are, but you can see right now, there's something going off to port 2000 at this end. Now, what's there? Well, there's not very much there. It's a little application that's just going to take the data and it's going to put it down here. So let me turn up the speed a little bit. Okay, so we'll let the thing go across. So once it finally reaches the other end, that computer picks it up and it puts it into its output window. Okay, and it says that a computer network is a digital telecom. Okay, it looks like somebody has spelt something incorrectly or they haven't even finished. Well, let's try sending another data. another packet. So here we go again. Sorry, it's a little bit jerky because of the screen recording. I'll stop it for a second. You'll see that source is again from the point 1.1 destination 10.45 going to exactly the same port number, which of course makes it appear down here. And here's Unication's network for sharing resources. Okay, so that looks a little bit funny. But of course, when you put both of those together, the received data says now that this is a computer network, is a digital communication network for sharing resources. Well, guess what? There's more stuff between nodes which are computing device. Okay, maybe it's devices. Okay, and you can see that, yes, that's devices that use a common telecommunication. Okay, and of course, well, yes, there's going to be a whole bunch of other data here. We'll let a whole bunch of data go through. Okay, so I'll send it one at a time, and I guess that's the end of it. And of course, what's happening is eventually all of the data reaches the other end, and it puts it together as a long message. Now, in reality, no, packets do not typically have only about 40 bytes in them, because that's what I've set mine to be. But you might be surprised they sometimes may not be much bigger than 40 bytes. Okay, for example, the thing called Ethernet, which all your computers are connected to, usually uses a packet size of about 1,400 bytes. Okay, and different types of things on the internet may actually have different amounts. Okay, so now that's the first thing is, yeah, we send out a bunch of data and this computer is responsible for putting it back together as a message. Now let me reload this page for a second because you see I've added a second slider down here called reliability. Okay, now what this means the reliability of the internet connection, because if you remember on my previous demonstration, sometimes things may get dropped. Okay, why? Well, maybe there's a switch inside that just got too busy. Okay, and if I roll this back to about here, what I'm saying is that this network is about maybe 50 to 60% reliable. All right, so let me slow it down so it doesn't go too fast, and let's try transmitting some data. So here we go. Here's a packet. And yeah, you know what? That packet made it. Good. Let's send another packet. Okay, that one made it. Now, of course, this entire thing is completely random, so I might... Oh, you notice what happened there? That one just disappeared. Okay, well, do you know what? This poor computer actually had no idea it disappeared. We know it disappeared because we saw it vanish, but this computer doesn't know it. Oh, and guess what? This computer on the right-hand side also doesn't know it. But let's try sending another packet. Okay, oh, that one also got lost. Let me try sending another one. Oh, and again lost. Okay, and again lost. Oh, that's okay. Oh, look at that. This one got through. Okay, perfect. So let's keep on sending all of the packets. Okay, so, okay, there's all of them. Okay, perfect. But now take a look at the message. It says a computer network is a digital telecommunication network for sharing resourcing physical cable media such as wireless methods such as Wi-Fi, microwave transmission, or free space optical communication. So you can see what's happened is, yeah, we ended up not getting our full message because, well, the internet is unreliable. Okay, the internet is completely unreliable. So if we just simply close our eyes and click send, which is what we ended up doing here, the number of packets that make it across could be quite random. Okay, so that's a bit of a downside, but this is an unfortunate reality of the internet. Sometimes packets happen to disappear along the lines. Okay, so what I'm going to do is I have to take a break for a second, and I will join this video with the next video. So just hang on a second. Welcome back to the continuation of the second video. Okay, you can see what I've got. I've got my little simulator back again, but this time the simulator's a little bit different. So far, it doesn't look very much different up here, but you can see I've got a couple of extra buttons down here. Okay, now, here was the problem that we had. So let me put down the speed kind of slow so I can stop the messages as they go across. In the previous example, I showed you the downside of simply blindly sending out messages one at a time without having any type of confirmation that the messages actually make it. Okay, so what I've done this time is I've changed up my simulation to be a little bit more complex. So what's going to happen is I'm not going to actually send the second packet of my data until I get back some kind of a confirmation from the receiver that they actually have it. Okay, so I think the easiest thing to do is for me just to simply get started with things, and then I can explain as we go. Now, the first thing up is I've set this up so that if you try to transmit, absolutely nothing happens yet. Okay. Instead, what I'm going to do is I'm going to begin with this button over here called Connect. Okay, and I'm going to start sending this one. And you can see that this data begins. It's pretty similar to what we did last time. Okay, so here, I'll wait until it reaches the middle and we'll pull it down so it stops. Okay, so let's take a look at this. It says here that the source is from the 1.1, which I said is on the left. It's coming from something called port 1000. That's irrelevant for this one, for this exercise. And it's heading off to the computer on the right, looking at port 2000. So something is at the other end ready to grab the data and to put it down here into the received window. So you can pretend this is actually an application on this side. All right. The new things that I've added, however, is I've added this thing right here called SYN. Sometimes people will call this a SYN. What this is an abbreviation for synchronization. Okay, and you'll see that I've included this extra word here called sequence. Okay, and what this is I want to have a conversation. Okay, so I'm this person here. I want to have a conversation with 1045 on port 2000. And this word right here called synchronization is essentially me making a phone call to that person saying, hey, are you there? If you are, I would like to start sending data with the numbers sequence numbers 15, because what I'm going to do with my data is I'm going to break them into numbers 15, 16, 17, 18, 19, and so on. And what I'm going to do is every time that I send over a packet, I'm going to have this computer send back saying, yes, I've actually received that. It's okay to go on with the next one. Okay, so let's bring up the speed and let's let the thing go across here. We can go a little bit faster. So this is the initial synchronization that goes across. But now take a look what happens as soon as this computer receives it. Notice that down here says undefined. There was actually no data at all, so nothing is happening. But instead, what you're seeing is that I've got this thing called an ACK. Okay, and of course it's starting from the right-hand side, it's going to the left-hand side, and what I'm doing is I'm telling the computer on the left-hand side who sent the message, I'm saying that I acknowledge your connection starting with number 15. Now, this is basically, yes, I want to talk to you. Okay, so if this is actually not that much different than if somebody calls you on the phone, you look at the number and you accept the call. Okay, that's what this is doing. Now, do you always accept the call? No, sometimes you're busy, and what you might send back is you may send back something called a negative acknowledgement, or called a NACK, so it's N-A-C-K. My little simulator does not do this, it only sends back ACKs. Okay, and there's other reasons why. Maybe nobody is actually listening on port 2000, for which would probably receive some kind of a rejection, or maybe the computer is already busy talking to another person, because I mean there are lots of other computers on the internet it could be talking to. Again, down here, this is the actual payload of the data, and right now it says undefined. I left it this way simply to remind us that there's absolutely no data. Okay, so what I'm going to do is I'm going to let this packet continue all the way back, and what happens is when the ACK makes it back to this computer decides that, okay, now I'm actually ready to start sending the data. Okay, well, let's actually try transmitting something. So you can see here we started to do a transmission, and okay, let me get it halfway across and we'll pause it again. Okay, so once again you can see where it's coming from, where it's going to. This time I've used something, the type is called DAT, and what this is I'm using sequence number 16. Okay, so sequence number 16, of course, is one bigger than the 15 that I started my communication with, and you can see this is the word a computer network is a digital telecom. Well, guess what? That's not much different than before. Here, we'll let it go a little bit faster, so we'll see the data go across, and as soon as this computer gets it, it processes it, and guess what? It also sends back an acknowledgement saying that, okay, fine, I acknowledge receiving the number 16. Okay, and if we wait for this one to go all the way across, and I do another transmission, you can see here that, well, now we've got the number 17, which contains the next little bit. Okay, So, and of course, what do I get? I get back an acknowledgement. Sorry, there's a little glitch up there in the upper left-hand corner, but this will be fine. And of course, notice the acts don't actually contain any data, but they could. Okay, but in this case, they don't. All right, and everything continues on. So we send this across. Here's sequence number 18, and as long as it makes it all the way across, then everything is fine. I'll end up getting back an acknowledgement for 18, and of course, everything will continue on exactly as we expect. Okay, so now the things start to become a little bit more interesting if I start to have an unreliable network. Okay, so let me reload this, and what I'm going to do is I'm going to start by making a connection, and I'm not going to change the reliability. In other words, it's 100% reliable. So right now I'm all set to go, but what I'm going to do is I'm going to drop the reliability of this message right now, or of this network. Okay, so something I hope will end up dropping. Okay, so let me slow down the packet a little bit, and we'll start by looking. So I am using the same sequence number each time. So the first thing up should be number 16. Okay, so there it goes. So let's see if it makes it through the internet. Okay, oh, and it didn't. Okay, now the thing is, who knows about anything? So first of all, this computer is already answered a connection saying, yes, I know somebody's about to send something, but the thing is if I'm this computer, I don't know if somebody has sent me anything or not. If I'm the computer on the left, I don't know whether or not my message is received. But you know what? I've been waiting now for about 20-30 seconds. I haven't seen anything. Guess what? My message probably didn't make it. So let me transmit again. And you can see what's happened because I never got an acknowledgement. I send out exactly 16. It also didn't make it. Okay, let's try sending it again. Maybe we'll be lucky and it'll make it all the way. If not, I'll increase my reliability. Good. So it made it all the way. So there's the first little bit. A computer network is a digital telecom. Okay, and okay, good. And we managed to get the acknowledgement all the way back. Okay, well that's pretty decent. All right, let's try it again. So what I'm hoping for is that maybe one of my other ones will not make it. Okay, so next we send packet number 17. Okay, good. That one's made it. Okay, the right hand side has picked it up, and here comes the acknowledgement back. We can always hope that okay, you know what? I'm going to kind of force it to disappear. Okay, here's what we're going to do. We're going to transmit this one, and as long as it gets through, I'm going to drop my reliability. So notice, oh, okay, so let me give it fully reliable. Okay, now that it's going, let me turn down the reliability. Okay, so now take a look at this on the way back because it's now a pretty unreliable network. Let's hope that acknowledgement number 18, see that? It went away. Now, here's the thing. The computer on the right has received packet number 18, but this computer actually has no idea. Now, let's put this all the way back up to fully reliable again and do another transmit. What packet will get sent? Well, let's take a look. Well, packet number 18 is going to go again, but because this one already knows it received packet 18, it's not going to include that. It's just going to send back an ACK. So it says, fine, fine, fine. Yes, I already have that. Please send the next one. And by the time the ACK gets back, it means that the next value we end up getting is the sequence number 19. Okay, so this continues, of course, until everything makes it across. Okay, well, for fun, let's turn up the speed. Okay, that's gone through, and I'll leave the reliability halfway. So here goes packet number 20. It made it. And let's see, does the ACK make it? Yes, it does. Okay, let's try it again. In fact, let's send another one. Notice that if I send two of them in a row, I ended up sending 21 in both cases because, well, as far as this is concerned, it's always the same thing. Now, I'm going to get back a bunch of, well, in this case, I didn't get back any ACKs at all because nothing actually made it. Okay, but this is the number 22. Even if you send it a whole pile of times because I never got the acknowledgement, I keep sending the old packets. Okay, now, here's sort of an interesting problem that happens. Notice that as the reliability goes down, sometimes you end up having to send the same packets more than once. For example, there's packet number 23, disappeared. I have no choice but to try sending it again. Okay, and yes, okay, it was sent again, and even the acknowledgement, if that disappeared, well, guess what? I end up sending the data again. So here's a bit of a downside to this. As the network gets busier, we start to lose more packets. And remember, that was exactly from the same simulator I did in the previous video. And by losing more packets, that's going to cause more retransmissions. Okay, which may end up resulting in more packet loss. So there's sort of a bit of a downside to this, and it actually tends to spiral out of control. Kind of like this. I've got a little simulator I want to pop up. Let me see if I can find it. Okay, right here. Okay, I think everybody will certainly agree with this type of thing, but let me switch over to this round thing. Okay, what this is a traffic. It's a big roundabout. And of course, roundabouts don't have any type of traffic lights on them, and everybody can just go around all that they want. But take a look at what happens if you end up putting, say, a 60 kilometer per hour limitation somewhere. Okay, unfortunately, okay, I believe everybody's already going 60. Okay, let's just put a little bit too much traffic. Okay, take a look what happens if you just get too much traffic on the road. You start to get this type of thing right here that you refer to as congestion. Okay, and even if I drop this down, this will actually take a little bit of time before everybody gets back. This is known as traffic congestion. And by the way, that's exactly the same thing that happens on this type of a network. Sorry, let me put this one away. This is exactly what happens on this network. We get something called congestion if you get too much traffic. In fact, what can really happen is you can end up getting something called congestion collapse, where there are so many retries and so many NACs going through that absolutely nobody can put any data through at all. Now, as an interesting thing, I found this article not that long ago. This was actually just from yesterday. Sorry, let me close up this one. Should be this one right here. Okay, take a look at this. Netflix is reducing its traffic on ISPs by 25%. Now, it says in India, but you know what? This is worldwide. Okay, take a look what it says. It says Netflix said Tuesday it is lowering its traffic on network providers by 25% in India. It's actually full. It's the entire world for a period of 30 days, following a similar move in Europe in a bid to reduce congestion on the internet pipelines as a result of COVID-19 pandemic. Okay, completely understandable. So think about this. You are sitting at home watching these videos. You are probably attending some online things, some Zoom classrooms as well. And guess what? All of this takes internet time. And as a result, there's more traffic than ever. And what Netflix is trying to do is they're trying to cut down on the congestion because they already know that the internet lines are pretty much at their capacity. And by allowing people to stream full resolution videos all the time, this is adding extra things. Okay, so this is adding extra burden, which is going to end up causing even more congestion. So something that actually fits along quite reasonable. Okay, so give me a second. I have to pause this video while I set up the next little section. So just a second, I'll be back with the next part. Okay, welcome back to the final little part of today's video. Okay, you can see that I'm back here once again on the 7 layers of the OSI model, and just to remind you, we were looking at this thing called the transport layer, which has to do with end-to-end communication. So it's actually getting the data from one end to, or basically from one computer to another. You'll notice the second bullet point happens to have two magic acronyms. One is called TCP, the other is called UDP. Okay, UDP is an abbreviation for the words User Datagram Protocol. And what a User Datagram Protocol is, it's called an unreliable datagram packet mechanism, where the only thing provided happens to be a source port and a source destination, of course, along with the IP address. Sound familiar? This sounds exactly like my unreliable network that I first showed you. In fact, that's pretty close to what UDP is all about. So it's unreliable. Sometimes people think the letter U stands for unreliable, but that's fine. It's a good way to remember it. Okay, and of course, the other one that I showed you called reliable, it's not exactly this thing called TCP, which is Transmission Control Protocol, but this thing called Transmission Control Protocol is a type of protocol that allows two computers to have a conversation without losing any data. And guess what it does? It uses sequence numbers and acknowledgements and things called handshakes to set up communications and other things to tear down the communications at the end. Yeah, it's not that far different than that little example that I gave, but I wanted to show you mine instead of TCP because TCP is really quite large and it has a lot of stuff that takes a little bit more time to understand. So I thought a better option would be just to make up a simplified version of this. Okay, but if you want, you can certainly pop open a Google search and take a look at TCP, and you can take a look at what some of the other features of TCP is all about. Okay, so the only thing I'm going to finish this off with is I'm going to ask you to ponder the following question. Okay, if you have the option between something that's reliable and something that's unreliable, which are you going to pick? And I'm sure you're thinking, well, who would ever want something unreliable? Reliability is definitely what you want. I mean, if you download something, you want to actually get the entire thing. Who would ever actually use UDP? Okay, well, I can tell you a couple things about it. Number one, if you're writing programs, I can tell you with quite certainty that UDP is a whole lot easier to program than TCP, simply because you don't have to maintain things that are known as sessions. It's not impossible, but it's certainly a lot of extra overhead that you have to worry about, and you have to know whether or not a session is disconnected, and then you have to try to reconnect later. Okay, so I mean, being a programmer, yeah, you definitely want UDP. Trust me, it's just considerably easier. But there's lots of data that's available that is actually not all that bad. That you can actually suffer with a little bit of data loss. Okay, the thing that really stands out, video. And I'm not talking about videos that you watch on YouTube, but I'm talking about live streaming videos like for Zoom. Okay, so you think about this. If you're watching an instructor get in front of a whiteboard and he's doing some kind of a demonstration, and suddenly the network drops or a few packets disappear, is it really important that you see every last little pixel? Well, sometimes it is important, but sometimes you just want to see the actual end result. And if you miss a couple of things along the way, it's probably okay. Okay, and that is certainly going to be true of, say, if you're watching a sporting event. I mean, who cares who passed to who, as long as you can see the final result, which is somebody put the ball into the net. That's probably the most important thing. So things like video often end up using, especially live streaming video, end up using this thing called UDP. Now, although we did see lots of packet loss, I can probably tell you it's quite safe to say that on a local area network, say within the college, the number of packets that get lost is pretty close to zero. It isn't zero completely, but it actually isn't that much. When you start getting across big long sections of the internet, well, then you start up getting into this idea of packet loss. Okay? All right. Do I have anything else? You know what? I think I've got one extra thing. So what I'm going to do is I'm going to stop this video. Please open up the next video because I got a small exercise for you to do. Okay, so that'll be the end of this part, but please check for the next one for the actual exercise.